Welcome to video example 9, Unit 2, Chemistry 1B. Here we're going to calculate the boiling point. Now remember, the boiling point is just the transition of a material from the liquid to the gas phase. Any phase change, as you well know, the delta G value is equal to 0. There's no free energy needed for a phase change to occur. So if we were to use the Gibbs free energy equation, we know that we could write delta G is equal to delta H minus T delta S. Okay, if we rearrange that equation, now that delta G is equal to 0, we could say 0 is equal to delta H minus T delta S. Okay, we could then rearrange this equation so it becomes T delta S is equal to delta H, and temperature can then be equal to delta H over delta S. Okay, so that's for any phase change, whether it's a boiling point or a melting point, or a sublimation for that matter. Okay, so we want to calculate the boiling point. We've been given the delta H value, and we've been given the delta S value. Okay, so the phase change is from bromine liquid to bromine gas. Okay, now remember guys, there's a discrepancy in the units because the delta H value is in kilojoules per mole, all right, and the delta S value is in joules per mole. So we have to convert either one or the other, and generally our convention has been that we convert the delta S value. So in this case, we can use the equation that we have the temperature is approximately equal to the delta H divided by the delta S over here. And we put the delta H value here, and then we put the converted delta S value here. So I'm taking this value of delta S here and dividing it by 1000 to get it in kilojoules per mole Kelvin, so that I can get an answer in Kelvin. Okay, so that the kilojoule units cancel here and the mole units cancel here, so my answer is left in Kelvin. And so you will see that for a temperature that is greater than 334 Kelvin, the delta G is going to be less than 0 and the reaction is spontaneous, which means that the delta S is going to dominate. For a temperature less than 334 Kelvin, delta G is going to be positive, and the reaction is going to be non-spontaneous, and the delta H is going to dominate. And finally, for a temperature equal to 334 degrees, delta G is going to equal 0, and the temperature is going to be the normal boiling point.